Jeremy is director for, I'm going to go ineni, Realtime. I'm not sure of the pronunciation. It's one of those names. It's an innovative building technology company, and he's also an academic focused on the development of real-time visualization industry.
Hold on a second.
So if you're into virtual technologies, 3D immersive environments, VR and AR, Jeremy is your man. He's a strong advocate of digital interactive models, and he's going to tell you about what's available now, why you should be using it, and how it can help you. Jeremy, did I get it right? And then
Yes.
in
any. Yep. Think in any industry,
Fantastic.
in any project.
I was actually looking at I was looking at the website earlier on, and it's fantastic. So take it away.
Excellent. So you can see my presentation?
Yes, I can. That's perfect.
Excellent. Thank you very much. Thank you for inviting me to speak. It's been an interesting day. All the presentations have been quite good. I've had them running in my ear as I've been doing other things. So been really good quality set of presentations and some really good projects coming along. So I guess we're going to finish up with the virtual tower, which is interesting because all the others have been about real versions. I'm going to talk about, I guess, virtual versions. So my background is I guess architecture. I started BIM about 20 years ago, programming GDL objects for ArchiCAD. So you could say I'm a bit of an advocate for all things digital. But from Laurie's comment in the panel earlier on today, I thought that I'd actually I'm a bit from the other side. You could say that I've gone down the technology hole and come out the other end. And I don't fully advocate technology in all situations. I think there's a very specific good use of technology, which will help us get there. That's about when we started losing quality of architecture. As you can see, this is from the McKinsey productivity report. It's not 2017, I think it was. I've never actually managed to see the whole thing. I think you have to purchase it if you ever want to see the whole thing, but I've managed to read little bits of it here and there. And this one image is the one which really kind of shows me. So what this is showing, there's lots of different interpretations of this image, but what it's showing is essentially how productivity over the last 50 or 60 years or so has affected industries. And it's more than just these industries. They did about 20 industries altogether, but these are the main ones, and it shows the trend. Pretty much every industry that applies a technological solution gets some type of productivity gain from that application. A really good example is something like Toyota automating their factory floor, manufacturing, boom. And you can kind of see it. You can kind of see it in this graph itself. Now, every industry except construction. And what's funny in our industry is what I seem to see is that every time we apply a technological solution, we actually lose a little bit of productivity. It's interesting. And you can kind of see it from about the mid-1960s, which is, funnily enough, when we started using CAD. So computer-aided design, and ever since then, you can see a slow drop-off in productivity. Now, this is just for the US, and I've had people argue that Australia looks really good, but what that misses is Australia is actually based on the US technology corporates that we all use. So it's interesting to see. So anyway, that's the context I'd start with, is that there is this kind of dropping productivity in our industry, which we're not solving. And we are trying to get there with things like prefab, a range of different modular technologies, automation. We're effectively trying to solve the problems with more technology, which I find really funny. And so that kind of brings us to us. So so I thought I'd start here and run a little video. So our mission statement: to empower people using visual information to create change in the real world. So pretty basic. What we want to do is have technology actually help us. And I thought I'd start with a digital twin, because that's what we all love talking about these days. We've all heard about them, but this is one that we created about 8 years ago. As far as I know, it's one of the few digital twins which has had 8 years of continual use. So there's lots of questions about what a digital twin is, but you can kind of see in this video well, the basic idea. You have all of your systems, your subsystems linked up to your building management system, all running in real time. So you can click on a 3D asset from the building information model, go through, maybe make a work order, something similar, kind of scan the whole building and really understand your living building or your operating building in virtual real time. So this is it. This is essentially how the industry is trying to get to this idea of digital twins. And you can kind of see, you can zoom in, you can make work orders, link it all together. Simple enough. This is running at Barangaroo and has been for about 8 years. I thought I'd start there because it kind of shows, I guess, what the digital twin is, but then I'm going to lead into where I see the real value of digital twins. So digital twin, I don't love the term. I've been doing this for about 20 years and it's just the current catchphrase which we're using. But one thing, and there's lots of different definitions out there, but I think we can all largely agree that the idea of a digital twin is to create efficiencies for all of us across the entire building lifecycle. That it should be able to tie together a bunch of things and make our buildings run better. But it's not a new idea. So one of the first digital twins I can remember is from quite a while ago. So this is Mission Impossible, good old Tom Cruise. And they filmed this in Sydney, and I find this hilarious. So they're attempting to break into a building with very high security systems. You might recognize the building if you've been to Sydney. Look at that 3D models. You can see we're pretty advanced even back then. Wireframe. Oh, and there's the real version, a digital twin. And what's really interesting is how good this digital twin actually is, because it's good enough that they can control the vents in real time, down to the millisecond, I suspect, and then drop, open it up and drop Tom Cruise in, floating, flying down through. Wow, it's really cool stuff. And look, so that's the idea of digital twins has been around for a while. For those that want to know, that was Arthur Phillip Tower in 1996. It doesn't have those systems, in case you want to know. It's got some pretty nice technology in there, but nothing that advanced. And to this date, I don't see it yet. So it kind of brings us to what I do and the digital twins that we create. And so where we've gotten to, I've gone pretty far down this digital twin realm, and we kind of create them for engagement. This is how a lot of people understand them. Leasing, nice, beautiful environment, visualization, effectively. Lots of nice stuff that you can use to sell your building. Operations is where we're kind of heading at the moment. The digital twin is effectively now trying to control the BIM, use the BIM information and link it up to the building management system to gain efficiencies and make good operations. Especially with the pandemic and COVID, we're seeing a huge push in this space because, well, we want our buildings to recognize people, maybe take the temperature of people. There's a whole range of tasks that we might want our buildings to do in the future. But I guess it kind of leads me down to the data. And so this is probably my most interesting project that we're working on currently. This is a defense project which we started at the beginning of the pandemic. You might remember they put a whole bunch of money into defense right at the start of it and said, we're doing some super advanced underwater counter warfare. And that's what this project is. So this project is essentially creating digital twins of the natural environment. And what we're doing is we're taking a whole range of stuff. So kind of 3D information, like scans of the bottoms of oceans using sonar data, barometric data, the fish type, igneous rock types, reflectivity of the sand, the temperature of the water, tides, a whole range of different information, both public and private. And we're ramming it all together. And what you see in that image is effectively created in real time, just using data from information. So there's nothing real there, but they act real. So the fish act like those types of fish do. The seaweed sways in the wind. There's a certain amount of sand which is in the water depending on the time of year about reflectivity. And we're using this to essentially find mines. So at the moment, it's a very dangerous task of sending people out into the water to get blown up at 3 a.m. in the morning usually. So we're looking to do that with a set of drones and so forth, making digital twins of the natural environment. So, and these are very, very complex digital twins, much, much more complicated than what we're creating in our industry. And it's led me to a really interesting point about data. So, and I'll ask this question, I ask this regularly, and this starts getting key to what is data and what are some of the problems in our industry. So what is the most asked question in any building in the world? And people go, oh, any building. And you think for a while, and you think, is it, you know, how's it running, how many people, like a whole bunch of different things. The most asked question is, where is the bathroom, please? Every single time, I guarantee it. Because that's what we do. We interact with buildings socially. So we come into them and we go, oh, I need to find the bathroom. Where is the bathroom, please? And what I've come to is, if your digital twin is very advanced, is doing all types of very tricky things with energy savings and so forth, that's great. But does it help 99% of people that visit your building find the bathroom? And that's the real value of what a digital twin is. So everyone's looking to data. Everyone's looking to big data to essentially solve all these problems in our industry. I actually have come to a point where I'm starting to see that the data is becoming the problem in our industry. Dealing with so much of it in, well, largely life, which we don't really want to deal with data, kind of raises some questions. So I'll have some questions about data, in fact, and there's some that you probably haven't really considered. So how much time do you spend on, or do we spend on email every day? If you look into it, it's approximately 30%. So business, depending on the type of business it is, will spend about 30% of its time on email. And email doesn't actually solve problems, from what I find. In fact, it takes a lot of emails to even find the people and the issues. It takes about 18 emails to solve any one issue. And so that's a lot of data being generated. And part of the reason we do 18 emails is because, do you trust data? And one thing I find when I ask this question is people go, oh, yeah, sometimes, with context, maybe. Or, you know, yeah, I have to, because it's the only thing I have. What else can I trust? But ultimately, we don't actually trust data. It's just fundamental. We just don't trust it. And unless we've seen it and verified it ourselves, we don't trust it. And we can kind of, it's a natural tendency. You kind of see this. So I've got a couple of funny videos. There's heaps from our industry, but they're not as funny. So this one is just a soccer game, football game. And it's, you know, not sure how important it is, but what's really funny is an AI controlling the camera. So not a man anymore, not a person. And that AI has been told to follow the ball. And the ball looks a lot like a bald head. And so this camera keeps flicking back to this bald head. Now, that's fine, it's a bit funny, but just say this was a very important game and that goal was predicated, or, you know, maybe a foul, you had to actually go back to the camera footage. So what we start finding is AI starts making mistakes, little mistakes here and there, which we have to fix. And this is chasing the tail problem of how much time and effort do we put in to design a system, which will, well, we can never totally predict. I kind of found that pretty funny. Another good one, AI Supercar. So this is multi-millions dollars worth of car. You can see this little guy down in the corner. He's watching it, and there it goes. AI. Oh, now let's watch that again, just because. Ouch. So this is supposed to go around the track really fast. They've tested it. It's going to get ultimate times. Ouch. So AI struggles. It struggles a lot because we don't actually understand how it's doing. An interesting kind of aside of that is there's a driving algorithm in Canada, which has been around for about, I think, 12 or 13 years now. And it's the best one. It's never crashed. It drives perfectly, except they've never used it because they used a funny way of training it. They basically let it look at other people to learn how to drive rather than kind of giving it a set of rules. And it drives really well. But the neural network that it's created is so huge that we don't actually have the computing power in the world to understand why it's making decisions. So we can't trust it. That ultimately the car could just run someone down and we wouldn't know why. So there's this kind of funny thing. It's led me to this point, maybe that there's this data axiom. And it's that every piece of data essentially begets more data. In order to just go get a data set, I need to go collect it and verify it. If I want someone else to see it, I then need to do a third action, which is store it. And then someone else needs to go collect it and verify it from where I stored it. And then they go, oh, Jeremy's an idiot. That's right. I don't trust him. I'm going to go collect it and verify it myself. So what we find is every time we store data, we actually come down to this really strange thing. So I've asked a lot of large organizations, big developers recently, how much data they have. This is a funny question. Not many can answer. One kind of could. And they said they think they have about a petabyte. But that was before he started considering backups, redundancies, multiple versions of different data centers around the world so their staff could actually access it quickly. And then the live data, which is kind of created and generated and disappears. And that's cool. But then it was like, well, how much heat is that generating? Because we're talking about environmentalism here in zero energy buildings, but then we're now storing data. In fact, I think about 15 years ago, the very nature of saving a piece of paper actually flipped to saving a note. So what I'm finding now is a digital note that you write was now going to exist for the next 50 years, be accessed about 1,000 times from AI, and actually generate a good couple of kilowatts of energy. So piece of paper with its own embodied energy, or a digital note, which is now going to be stored and duplicated for the rest of time. It actually raises some really interesting questions about what data is and how we should be dealing with it and storing it, especially as the built environment. So what is all that? It's all data, but what it does lead me to is effectively what we kind of do and how we do it. And we create virtual digital twins of, I guess, the built environment. So this is a video created from one, just visualization output of a tower. Oh, excuse the bad quality there. And it's virtual, it's interactive, and it was created for a range of purposes throughout the life cycle of the building. The idea is that you can kind of enter it, you can walk through it, you can start interacting in real time with this space, kind of virtually before it's built, but also after it's built. So after it's built, this can become a simulacrum or a way of actually controlling and operating the building. So back to this very fundamental idea of digital twins, which is great when we think about facilities managers. But I have often asked facilities managers, do they use their digital twins? And they go, yeah, I'm told I have to. The reality is they don't use a digital twin. When a facility, if you ask a facilities manager what his job is, it's usually this. Oh, g'day, Jill, how you going? How are the kids? Oh, good, John. You know, I'm a bit warm on level 4. Is there something wrong with the air conditioning? I don't know, I'll have a look. And he has to deal with about 300 of them a day. So does he really want complex systems? Probably not. But Jill could probably actually use a digital twin to assess some of these things themselves. If we can make it really intuitive and nice, if we can actually start linking it to their real experience in the real world, then it just becomes a way of operating and interacting with the building. A point where the virtual environment becomes as much as the real space as the real building itself. Because how much time do people spend on their screen these days? I'd say most people spend the majority of their time already in virtual space. What we don't have is really well-designed virtual spaces which interact with our real spaces. And so you can kind of see with this one, this was used largely for a range of purposes to kind of, this was fairly early. I think the building has changed a bit now. But you can kind of see kind of how it worked and the concepts behind it. And quick ways of kind of doing floor plans. Oh, and if you need, and this is what I really like about this, and we've done this for quite a few buildings, you can make maps of where the toilets are. So for pretty much no extra cost, at the end of the project, you have a really detailed version of what's there. And operations are great, but soft operations. So toilets, your grandmom coming to visit you on level 14, all these little pieces. This is actually what becomes really vital in how we operate and live and socialize in buildings. So that's, of course, this is all interactive. I can kind of bring these up and show you. And I do like to do these things real time because these things, oh, that was a funny one. Let's go to the next one. So I think my computer's doing a funny thing. I do like to kind of essentially interact with these things in real time to show that this is how we should be doing a lot of this stuff. So this is one we did for a hospital recently. Wasn't a tower, but I've kind of brought it up because we actually, well, we're doing another, well, we're doing a school and a medical facility in a tower. And this one was kind of made for client engagement. So, and what the problem was, we did this, started this right at the beginning of the pandemic, and they were going to build a whole bunch of kind of physical spaces and walk all the doctors and nurses through them. But that became a bit of an issue with social distancing and so forth. So we created a set of virtual environments for them. And then we did a bunch of kind of town hall sessions where we, let's go to the operating room, where we essentially got them to interact with them. And some of them were in virtual reality. It was a range of different medium and formats. Some people were on screen, some people were viewing in a kind of lecture theater scenario. And what we did is we allowed them to interact with the spaces. In the virtual environment, these are actually interactive, so you could move them around, check clash detection, see if it all worked, and see how it all went. Little funny things came out. So this room looked great and it was all pretty much finished, but they spent an inordinate amount of time looking at this corner because that was a dust catch. And they're like, we can't have that in an operating room. And that would have made it through. That would have made it through construction and so forth. So, but the other thing is that then at the other end, we can start thinking about these in terms of training and so forth. So I'll move out of this one. There's a lot of rooms. We're now actually working on this one to create the whole hospital. But you'll kind of get the point. I'll just finish up on this one, which is kind of training and safety. So, so this is a tunnel boring machine. And I thought I'd include this because it's a little bit like a tower or a skyscraper, but the difference is that it's lying down on its side. So, begin this session. And this one was created to instruct and take people through very dangerous environments before they could get to them. In virtual reality, this is actually quite a frightening experience. So this is the first time that I've ever been convinced by virtual reality. Because being in these spaces, let's go to an interesting place here. Here we go. And so when you're actually standing in these places with these giant pieces of concrete and metal, and we had very good sound effects in here too, you get a sense of how easy it could be to die in these places. And we kind of like moved on from there. So just that's training and safety. That's virtual reality. I'll finish up there. I think I'm being told to get out. Sorry. And yeah, I'll just kind of finish it up with, if you'd like to read an interesting book on some of this stuff, there's Interfacing the City. It's a collection of academics that have written about smart cities into the future. Thank you very much.
Thank you, Jeremy. That was intriguing and a great way to finish. I think some of the videos or the interactivity wasn't coming across to us, but I urge all the delegates to go and look at your website where you can see some demos of all of that stuff happening. It was great to have you here to finish us off today. Everyone, please wave your hands in the air like you don't care. And Jeremy Harkins, thank you very much for being here.
Thank you very much.